Hello everyone, welcome to BotTales Lab. Today I'm going to teach you what are motors, what are different types of motors and what are its application. That is our today topics in introduction to motor. So let's get started. So there are two types of motor that we are going to learn today. First is DC motor and another is servo motor. So on left hand side, this is how DC motor looks, and on right hand side, this is how our servo motor looks. Today I'm going to teach about small DC motor and small servo motor. So let's see what is DC motor. A DC motor is an electrical machine that converts electrical energy into mechanical energy. Small DC motors are commonly used in toys, small fans, and electronic projects due to their simplicity, ease of control, and affordability. So basically, DC motor means direct current motor. It is a machine which converts electrical energy into mechanical energy. Means basically, sensors are the equipment which convert mechanical energy into electrical energy, but motors are equipment which converts electrical energy into mechanical energy. Like you can see on your house motor or pump, all the other things that convert electrical energy into mechanical energy. So what are some of the application of DC motor? So its application are a DC motor are used in toys, remote control cars, helicopter and robot. They are used in small appliances like electric toothbrushes, hair dryers, and battery-powered fans. They are used in DIY projects like automated system, motorized mechanism for hobby electronics, etc. So let's see what are some of the components of DC motor. So our DC motor are different components like stator magnets, rotor coils, commutator, brushes, shaft. Let's see each and every component in detail. So what is stator magnet? It is a type of permanent magnet. It provides a stationary magnetic field inside the motor. Let's see what is a rotor, or you can say armature. It is a rotating component where the mechanical motion is generated. Let's see what is commutator. A commutator is a rotary switch that reverses the direction of current in the rotor winding, maintaining continuous rotation. Brushes. Brushes conduct electrical current between stationary wire and the rotating commutator shaft. The central axis connected to the rotor which transfer mechanical energy to external devices. Basically, starter is a permanent magnet which is used to produce magnetic field which helps in the rotation of motion. This magnetic field generated helps in the rotation of a rotor which is called as armature. Armature is made up of many tons of copper wire that is called as winding. Because of magnetic field, the current is generated, and because of this current, armature rotated and connected to that armature commutator brushes after there as the armature rotate that we can say a rotor rotate or commutator rotate, and accordingly a shaft rotate. The commutator is used to change the direction of our motor, that is till half turn our motor will rotate in one direction, and after that our motor will rotate in another direction. And brushes are used to provide conductivity between stationary wire and rotating commutator which helps in changing the direction. And shaft is a device which provide that rotation to the other devices. You can connect other devices like fan or gear to this shaft which will help in rotation of other devices. Let's see working principle of a DC motor. Small DC motor operates on a principle of electromagnetism. When an electric current passes through the rotor winding, it creates a magnetic field. The interaction between this field and the stator's magnetic field generates a force, causing the motor to spin. The commutator reverses the current direction every half turn to keep the motor rotating. Basically, the DC motor is based on the principle of electromagnetism. When an electric current is passed to the DC motor, a magnetic field is created due to this magnetic field. Rotor winding rotate on the basis of Lorentz force. and the commutator is used to reverse the direction of our motor. Then there are two types of DC motor. One is brush DC motor and another is brushless DC motor, which is also called as BLDC motor. So let's see what is brush DC motor. It uses a brush and a commutator for current direction switching. In brush DC motor, brush and commutator are present, and in brushless DC motor, brush is not present. It uses electronic controller for higher efficiency and longer life. It uses electronic component to change direction. Okay. Now we will see what is servo motor. So a servo motor is a type of motor that is designed to provide precise control of angular position, speed, and acceleration. It differs from other motor because it can move to a specific position and hold it. Basically, what is a DC motor? Basically, a DC motor rotates continuously. When we provide supply to it, it will rotate continuously, either clockwise or anti-clockwise. But what is a servo motor? We can control the position of servo motor. That is, a servo motor rotate in the form of angle. We can control its speed, acceleration, position, etc. That is, a servo motor we rotate in the form of angle like 90 degree, 180 degree, 360 degree, again 180 degree, 90 degree. It will rotate in angle to angle. So we can control its position precisely. Some key characteristic of our servo motor are precise, that is, it can provide exact position control. Complex and small servos are lightweight and perfect for precise tasks in robotics model. Making another application, rotating range typically rotate between 0 to 180 degree. Some motor have full 360-degree rotation. Let's see some of the application or usage of servo motor. Small servo motor are used in application like robots for controlling the movement of robotic arm. We can use a small servo motor for controlling the movement of robotic arm or legs. RC vehicle for controlling steering or throttle, control for camera for adjusting camera angles, or we can say for rotating camera to particular angle, toys and automation moving parts of slab. Okay. Now let's see some of the component of a small servo motor. A servo motor different components like servo arms, gear train, DC motor, potentiometer, control unit. Let's see each and every component in detail. So motor, the main component that drives the mechanical movement, usually a DC motor coupled with a gear mechanism to control rotation precisely. Basically, inside of servo motor, a DC motor is there, which is used to control the position of a servo motor with the help of gear. That is, one DC motor is there and connected to different gear are there. And as a DC motor will rotate, this gear will rotate, and according to the movement of this gear, the shaft of our servo motor, that is known as servo horn, will rotate. Okay, now controller. Controller receives PWM signal that control the position of signal. So what is PWM signal? PWM signal is a one type of signal by which we can control the speed of motor according to our need, or you can say angle of motor. So basically our controller receives PWM signal from a microcontroller, and according to that it will control our motor. Control the motor position by changing the width of the pulse. So short pulse, lower position, long pulse, high position. Feedback mechanism, potentiometer provides feedback to ensure the motor reaches the correct position, adjust the motor to stop our precise angle. So in our servo motor, one feedback mechanism is provided, or you can say potentiometer. What the use of this? It is used to detect the position of a motor. It will check previously at what position our motor is there, and according to that it will make rotation of our motor. Okay, let's see gear. A set of gear is used to increase torque and provide mechanical advantage, making the motor suitable for precise movement. Basically, gears are used for making the movement of our motor, that is in which angle we want to turn motor. It can be done with the help of gear. Okay. Let's see working principle of a servo motor. Basically, The controller of a servo motor receives a PWM signal which is in the form of square wave that specifies the desired position. The servo motor uses this PWM signal to adjust its angle. The motor turns to the specified angle and then holds the position. It uses feedback from the potentiometer to ensure accuracy. Angle control: when the PWM pulse width is adjusted, the servo motor will move to a new position. 1 microsecond pulse with 0 position, 1.5 millisecond pulse 90-degree position, 2 milliseconds. So basically, our controller of motor will receive PWM signal from the Arduino, or you can say any microcontroller. The PWM signal is basically in the form of square wave. That PWM signal is used to adjust the angle of motor, that is at which angle you want to rotate your motor, and the feedback mechanism is used to check the previous position of a motor and to ensure accuracy of the motor. When the PWM pulse width is modulated, the servo motor will move to a new position, and according to the feedback mechanism and your PWM signal, your motor will rotate in whatever angle or direction is specified in your code. And it will rotate 0 degree. If 1 millisecond pulse width is there, it will rotate 190 degree. 1.5 millisecond pulse is there, it will rotate 180 degree. If 2 millisecond pulse is there, and for 360-degree motion, it will rotate 4 milliseconds. Okay. So let's see summary of today's lecture. What we learned today. That today topic was introduction to motor. We learned two types of motor: DC motor and servo motor. What is DC motor? Basically, a DC motor converts electrical energy into mechanical energy. It is a type of motor which you rotate continuously, either clockwise or either anti-clockwise. Later we learned about components of DC motor, its working, etc. Later we learned what is servo motor. A servo motor is also type of device which convert electrical energy into mechanical energy, but it will not rotate continuously. It will rotate in the form of angle like 90 degree, 180 degree, 360 degree, etc. Later we see some of the component of servo motor and then working principle of servo motor. Okay, that's it for today. Thank you.